ammeter as well as voltmeter in electrical circuits for measuring current strength and current voltage. These are the electrical circuits. This electrical circuit and this is also electrical circuits. We have a source to produce current and the load to consume current. That is a kind of circuit. In these circuits, for the measurement of current strength, we can use ammeter, a device directly in the circuit. For the measurement of voltage, we can use voltmeter directly in the circuit. If the ammeter is there, it should be connected in series with the circuit. Series means connection in series with the source as well as load, like this ammeter. This device directly records the current strength or current intensity in the circuit. If you have voltmeter, to measure the voltage or potential difference across the load or in the circuit, like this. This is a load means current consuming device. You have to connect voltmeter in parallel to the load, in parallel to the circuit. Look at the difference. Ammeter should be connected in series with the circuits and voltmeter connected in parallel to the circuit, like this. Then only we can record the voltage and current. That is a way of measuring the current strength and current potential. Now the question is, galvanometer can be used as well as ammeter and voltmeter. If you replace ammeter by galvanometer, similarly, if you replace voltmeter by galvanometer, what will happen? These circuits usually have, that is, large amount, quite a source, large amount of current. If you connect it to a galvanometer, as you know, it is very sensitive, which measure only a small amount of current in micro or milliamperes. If you do so, it cannot withstand that electrical load, that amount of current. It is getting damaged, which we cannot repair it. That kind of damage produces. It is caused in the galvanometer. To avoid that damage, we use some manipulations in this circuit. What is the manipulations? Here, to replace ammeter by galvanometer, you have to do one more connections like this. This is galvanometer. One more connection is a conductor of very low resistance should be connected in parallel to the galvanometer. If you replace A by G, there should be a connection like this in parallel. This is a conductor of very low resistance. This conductor is known as shunt. This is the name of the conductor which has very low resistance, that we make by using special metals. It is known as shunt. The resistance of this conductor is symbolized also by S, and resistance of the galvanometer is also symbolized by J. Every galvanometer has a resistance because wire is there, winding wire. By doing so, what happens here? I is a current, is quite large. This current, this galvanometer cannot withstand. Now the current will divide into two ways. That is, bypass or alternate path. Here through this bypass or alternate path, major amount of current pass or flow. Major amount of current flows through it. Got this? Very low resistance. Very low resistance means more current flows through. So here current will divide. If Ig, what is I? Current flowing through the galvanometer. It is a minor, micro amount. And this current flowing through this galvanometer is less than this Ig. What is Ig? Is the maximum current this galvanometer can withstand, or current for the full scale deflection. And here a major amount of the current pass through this alternate path or bypass. With this technique, the damage to the galvanometer can be avoided. This is how you are using this manipulation or this type of a circuit. And what kind of manipulations we do in this voltmeter? If you replace voltmeter by galvanometer like this, here galvanometer, and while replacing galvanometer, you see that there should be a conductor of very high resistance connected in series with the galvanometer, not in series with the circuit. Here, voltmeter replaced by G and R in series. Series means very high resistance. This is galvanometer has a resistance. If you connect a conductor of very high resistance, what happens? Very high resistance will prevent a large amount of current to flow through it. Very large current, very large very high resistance will allow only a small amount of current to flow through the galvanometer. What is the small amount? The amount is less than Ig, which can withstand. And the major current flows through this load. The load has resistance R. What is the current flowing? At this point, current will divide through this Ig and through this I minus Ig. Major current pass through this and minor current pass through this. So this will avoid what is called overloading, electrical overloading at the galvanometer. Safe. So with these connections or with these electrical circuits, let us apply the formula. That is the simple formula for the conductors which are in parallel connection. These two are parallel connection. Look at this here. With these manipulations, this is a conductor of resistance G because galvanometer. This is a conductor of resistance S. Current flowing through is I minus Ig. Current flowing through is Ig. Total current is I. We divide this. Now between A and B, what is that? At this, across this, between A and B, the voltage remains same. That is, voltage across this remains same. So write Ohm's law. Voltage is V is equal to IR. That is, voltage across this. That is, voltage between A and B is V. Current into resistance. Current is Ig and resistance is G. And here V is equal to current. What is the current? I into Ig into S. That is the resistance. So these two left hand side is same. Therefore right hand side must be same. Equate the right hand side since they are connected in parallel. This is the formula, standard formula for any conductors which are connected in parallel. This is the equation we get. If you get this equation, we can write it as S is equal to Igg divided by I minus Ig. Similarly, I will tell you significance of this equation later. You come here, in this, here again, two conductors which are connected in parallel. This is one conductor having two resistances. Current flowing through is Ig. This is another conductor load having resistance small r. Current flowing through this conductor is I minus Ig. Again between point A and B, voltage drop or voltage is V equals this current into resistance. where R stands for load resistance. And across this, the total resistance is G plus R. G is the resistance of galvanometer. R is the resistance of this conductor, where high resistance of course. G plus R. So total resistance of the conductor into current passing through is Ig. So V is equal to Ig. Among these equations, this equation is not important. This is going to be very important. This finds significance. Let us understand what is the significance of this equation and what is the significance of this equation. Once you arrive at these equations, now see that. Understand in terms what is Ig and G. Ig means current for full deflection. Maximum current the galvanometer can withstand. G is the resistance of the galvanometer. These two are fixed values. For a galvanometer, these two remains constant. And this is constant. What are the in this equation? These two are variables. S and I. What is I? Current in the circuit. That is quite a large amount of current in the circuit. Comparatively, it is very large to Ig. So this current which we measure, that is current in the circuit, we supposed to measure by using galvanometer. By using galvanometer, what value of S is supposed to use? These are variables. If it changes, I also changes. So by fixing S, we can find out what range of current we can measure using galvanometer as a ammeter. Look at that. I means maximum current which we can measure. What range? Always maximum current is suppose 10 ohms. It becomes then 0 to minimum is 0 to 10 ohm maximum. So for the measurement of this range of current, what is the suitable value of S we apply here? Accordingly, we will fix it. What resistance of shunt we supposed to use to measure this range or the other range, because for different ranges you have different S values. Look at that, what range of current produces the current. Looking at that, we have to use the S. That is the importance. We work out problems on this equation. And the same concept is applied. In this equation, Ig, G are constants. Once the galvanometer is getting constructed, that is are found finished, this Ig value, current for maximum deflection, and G, resistance of the galvanometer. These two are constant and V and R are variables. If R changes, V changes. So we can find out that what voltage we are measuring in this, what range of voltage we need to measure. Depending on that, we use value of R. So by using a different value of R, we can find out what is that, what range of voltage we can measure using galvanometer. Galvanometer can be converted into voltmeter of different ranges by using different value of R. Here, galvanometer can be converted into ammeter of different ranges of current by using different values of S. That is significance of this. So this is what the technique you are applying when you use galvanometer as the ammeter and galvanometer as a voltmeter. So this is what the concept is involved. On this equation, let us work out problems, then you understand clearly the significance of the equation. The problem is on this equation, given the value of G, that is galvanometer resistance is 100 ohm. Different galvanometers have different resistances. And Ig for galvanometer is 1 milliamp. Current for maximum deflection. Ig equals, this is given values. And we have to convert this galvanometer into ammeter of this range 0 to 10. If you want to convert this galvanometer into ammeter which can measure a current range of 0 ampere to 10 ampere, what is the possible value of S to be fixed here? That we have to calculate. That's one problem. And the other problem is the same thing. And to convert this galvanometer into a range of 0 to 5, to measure the current of 0 ohm to 5 amp, what value of S is fixed over? The same one, we have two problems. For the solution, you have to use this equation. This equation is the one we apply. In this equation, G is given, Ig is given. Ig is not in SI, always substitute in SI because ohm in SI, it is in milliamp. Milli means 10 to the power of 1 milliampere. Milli means 10 to the power of minus amp. Into this divide by I. What is I? Maximum value of ampere. In this case, 0 means this you have to substitute 10. And Ig is same as this. Simplify, numerator is this, denominator is this, because this 10 minus this 0.001 almost same as approximately divided by 10 is same. Simplify 10 to the power minus 2 approximately ohm. So this ohm, look at very low resistance, 10 to the power of minus 2, 0.001 and 0.01 ohm should be connected here. When you connect that ohm of resistance, the galvanometer can measure this range of current 1 ampere, 2 ampere or 5 ampere, 9 ampere like this. Can you measure the current in this circuit? This is what we need to understand. Next, second problem is the same thing. To convert this into this range, same equation, that is these two data are same. So numerator is same for this. And I, what is I? I is 5. For this range means maximum 0 to 5 means I you write 5 minus the same thing is 10 to the power minus 3. Simplify, this same as numerator, denominator. And this divided by this is 0.02 ohm. So shunt range, what is that? The shunt resistance should have 0.02 to convert this galvanometer which can measure this range of current. Is it clear here? Now the problem on the voltmeter. Use this equation. Now given the galvanometer resistance is 50 ohm. Here the galvanometer is 50 ohm. And you are not given directly Ig, you are indirectly given this data. What is that? The galvanometer has 25 divisions and the galvanometer scale is, this is 4 into 10 to the power of minus 4 ampere per division. Per division, this is an ampere, that is magnitude of current. And how do we calculate Ig? Because with this data you can calculate Ig equals this into this. Per division so much of ampere, for 25 divisions, maximum 25 divisions. Then the current, maximum current we can record is Ig is the current for full plane, full scale deflection. Calculate this, we get this. Then use this equation. V equals Ig into G plus R. Ig is calculated, write this equation. What is V? The problem here, you have to calculate what is R to convert galvanometer into a voltmeter of range. This is one range, this is another range. 0 to 2.5 volt, another is 0 to 10 volt. V 2.5. For this range, V equals 2.5, right? The maximum value of this range. And Ig is 10 to the power minus 2 into G value is given is 50. R value to be calculated. Simplify, this becomes, simplify this, send this to left hand side. 250 equals 50 plus R equals 200 ohm. What does it mean? 200 ohm. You have to connect the resistance, that is conductor of 200 ohm. Here this galvanometer can record the voltage range of this circuit between 0 and 2.5. 0 and 0 to 2.5. For this range, do a similar problem. Use the same equation, V is equal to Ig. This value V, what value take? Maximum voltage measurement, 10. Ig equals 10 to the power minus 2. What is calculated? G is same for the device remains same. Plus R, calculate R, simplify. This is 1000 equals, when is simplify 50 plus R equals 950 ohm. 950 ohm. Look at this, very high resistance is required to increase the voltage range. Voltage range is 10 volt. To increase the voltage range to be measured using galvanometer to 9, what is that? 0 to 10. What value of R to be substituted? Here 950 ohm, very high resistance. Look at this, the technique is used. So depending on the what is that range of current in the circuit, range of voltage in the circuit, accordingly we have to choose the shunt resistance and resistance like this to convert galvanometer into ammeter and voltmeter.